you. All right, please stand. Let's pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession, was left unaided. Inspired by this confidence, I fly to thee, O Virgin of Virgins, my Mother. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of the Word incarnate, despise not my petitions, but in thy mercy hear and answer me. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. A few things. I do regret to inform you the tests are still in progress. Sorry. I'll try my best to have them tomorrow. Pray for me. Second, that people asked a follow-up question of, does that mean we have homework tonight? I'll tell you in a minute. Actually, I'll tell you in about 30 minutes. You have to have something to look forward to. And third, take out your notes. I found the problem that I was trying to remember at the end of last time. Suppose a circle has a y-intercept of 3 an x-intercept of 1 and 9. Find the equation of the circle. You might remember this symbol for circle from geometry. It's a circle with a dot in, so it doesn't look like an O. Now, that doesn't give you very much. What would you do first? Actually, before we even start, can somebody give me the equation of a circle? Try to do it without peeking, but peek in your notes if you must. Yeah.
Parentheses.
2 parentheses, okay.
X minus h
X minus h
squared plus x minus k.
Already used x.
The y minus k
Y minus k
equals r squared. The
squared equals r squared. Correct. H comma k we've seen before. We used to use that for vertex of a parabola. We still will. But h comma k is basically the starting point of any of these graphs. A parabola starts at the vertex, h comma k. A circle starts at the center, at least counting from the center, h comma k. Does that make sense? You notice there are 2 subtractions because they're inside the parentheses, they're inside the squares. There's kind of sort of inputs. Where is the center, first of all? Josh? H comma k. And what does R stand for? The radius. Good. So if you know the center and if you know the radius, you should be able to give me the equation of the circle. But you need those 2 things in order to give me the answer. They gave you neither. They gave you a bunch of intercepts. So what would you suggest we do? Oh, mathematical detectives. What would you do if I just put this set you guys on the test? Cry. There we go. Graph it, yeah. There are only 3 things we know how to graph on this. The y-intercept of 3, x-intercept of 1, I'll mark these. And an x-intercept of 9. Let's see who remembers this from first year algebra. Do you remember things called quadrants? Like quadrant 1, 2, 3, 4? Where are they? Which one is which? Like when you're graphing. Which one is quadrant 1? Good, awesome.
The one on the right.
I'm sorry.
Top right.
The top right. And these use Roman numerals. Where's quadrant 2? Yeah. Top left. Quadrant 3? bottom left. And then finally, bottom right. Those are the quadrants, quadrants 1, 2, 3, 4. You notice they're a little bit weird order? If we read a book or something, we go from left to right, and you scroll down through the lines. So I would have expected it to be 1, 2, 3, 4. It didn't. There's a reason for this. We're actually going to cover this. We covered it a little bit last year, but note, you're going what we call counterclockwise. That's going to come back next chapter, chapter after this. Maybe 2 chapters. We'll see. But which quadrant do you think the center of the circle must be in? Look at the evidence so far and see if you can piece it together. Is the center of the circle in quadrant 1, 2, 3, or 4? What's your instinct? Go.
1.
Why do you say quadrant 1?
Because it's smaller at the bottom, so these little bit bigger than everybody else.
Yeah, first of all, in order to hit up here, trying to go below would miss one of the 2 dots. If you wanted to go this way, it would miss this one. If you try to go this way, it would miss this one. It has to hit all 3 dots. And the only way to do that, is there another y-intercept anywhere, according to the data? Okay.
Can you repeat your question?
Yes, welcome back. Is there another y-intercept, according to the data? No. What's the only way you could get a circle to hit once and only once? Like, could it be like this? No, why not?
Because
Yeah, you'd have 2 y-intercepts. The only way to do it, I'm wondering if anybody remembers the technical term for this. What do you call it when a circle hits a line once and only once? Like this. Here's a circle. There's a line that just barely touches. There's a special name for that line. Oh, geometry, remembering people. It's what line? It starts with a T. It shares a name with a trig function, actually. I heard it. Good. Tangent. This is a tangent line. Just for reference, if you have a line that hits twice, that's called the secant line. Trigonometry stole a lot from algebra when they got their names. And they are kind of sort of related. But, is everybody clear? The reason I bring that up is because this circle must be tangent to the y-axis. It must just barely touch the y-axis once, and that's it. That's kind of useful. Now, there are some theorems in geometry that would help us to solve this. But, oops, that was very well. Does it make sense? Look at the y-intercept. It's at 3. Does it make sense that if it just barely hits at 3, then there'd be an equal amount above and below? Just visually, does it kind of make sense? So if you kind of make an imaginary line going across. Yeah.
I just have a question.
Mm-hmm.
I was just wondering what happens, or what is it called when a line hits a circle 3 times?
Can't. Circle can't. Line can't bend. Sorry. Does everybody see that there has to be a center somewhere in here? Can somebody give me one of the 2 coordinates now? Just by doing the visual. Go. The y is 3. The center is something comma 3. Does that make sense? If it just barely, kisses the circle at one point, then it has to be directly in line with the center. I don't know if anybody remembers this. There's a theorem in geometry which says that if a radius and a tangent intersect, then they must be perpendicular. And as such, it has to be straight across, because perpendicular is straight across from that. That means the center is on that line. So it's something, 3. There's another thing. Another theorem, again, I'm not expecting you to remember these, but they're kind of interesting. And it proves, if you have this is a secant line. If a radius is perpendicular to the secant line, then it must also bisect that, what they call a chord. If this little line segment here is perpendicular to the radius, then it must also be bisected by the radius. In other words, it aims straight through. All we care about, I mean, that's an interesting theorem from geometry, but all I care about is if I dropped a radius, well, it's not a radius, but a little stem there. If it's perpendicular to this line segment, it also breaks it in half. Can somebody give me the first number of the center? Take a wild guess. Say it. 5. How'd you get 5? Right, and what about the counting told you? What are you counting for? What are you looking for? Here's 1, here's 9. Where'd you get 5? Go.
Like the number between them.
It's exactly halfway between. It's the average. Yeah.
So, just a question for the tangent and secant lines, are those only in relation to circles?
Interesting question. Question is, could you have a tangent line to anything other than a circle? As yes, you could. They're most commonly with circles, but you can do ovals. You can actually do parabolas. You can get a line that's tangent to a parabola. That looks kind of cool, but it's hard to do. If you're graphing, it would look like this, and it would just hit at one point. It's tricky to do, but you can do it. Basically, any curve in any line could be tangent, or they could be secant if it hits twice. So, you're 2/3 of the way done to the problem. Just by this little detective work, just by a little bit of geometry memory, we know if it's tangent at this point, the circle center has to be straight across from it. And if you have 2 different intercepts, the other part of the center has to be exactly halfway between. That's going to be useful. We can now get 2/3 of our answer. X minus something squared plus y minus something squared equals something. What do I put here? Becca. I want h. So h is the first part. You want it? 5. And what's the second one? 3. Exactly. X minus 5 parentheses squared plus y minus 3 parentheses squared. We're 2/3 of the way done. All I need to find now is the radius. So, how? Nick, are there any, first of all, is this a radius? No, radius has to go to the edge. Now, I have no idea where this point is, so I can't measure that. Is there any edge point that would be useful?
Yeah, there's 0, 3.
Interesting. How long is that?
3. No, 5.
It's 5. Guess what you just found? You just found the radius. Now, if I had been totally sneaky, if I had moved this out, this was actually pretty nice. There's another way to get that 5. You could also have gone here. And geometry, remembering people. That's a right triangle. This was 3 units long, and if you count this, this is 4 units long. 3 squared plus 4 squared is 5 squared. Pythagorean theorem. And you should be able to get the radius that way too if you get stuck. If it's an easy radius, grab it. Grab it and run before they come to their senses. If it's not an easy radius, use the Pythagorean theorem, and you should be able to get the radius. This simplifies to x minus 5 parentheses squared plus y minus 3 parentheses squared equals 25. That is your answer. Does that make sense? Okay. Now I want to give you a heads up of what's coming up in the next 2 weeks. The very first section we're going to do is on circles. I want to do one more problem involving circle. Oh, sorry. Is anybody still writing that? I just automatically started erasing. Is anybody still doing this? I did a panic attack. Like, no, Mr. Geiger, no. You just destroyed my life. By the way, it'll be on YouTube, so. Try this. People are asking, for example, solve that system of equations. Now, we've been through systems of equations. There are multiple ways to solve these things. There is substitution. You can graph it, I suppose. Graphing, substitution, and remember another one? Elimination, and remember another one? You used determinants of matrices. Yeah. Kramer's rule. And remember, there was a fifth one. Augmented matrix, okay, I didn't remember that one. Fifth. And then sixth, there was something called A inverse B. That was inverse matrices. There are 6 different ways to get, you don't have, if you're saying like, I don't even remember that concept at all, don't worry too much. If you know how to do substitution, elimination, it's nice if you do Kramer's rule because it's actually faster than the other two usually. But the substitution elimination should be good enough. We have a bit of an issue here. In the past, when you did substitution, elimination, Kramer's rule, blah, 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 there were 2 lines. This is not. What shapes do we have here? Evan, what shape is the top one? Like if you graphed it.
Oh, just a line.
It's a line. What about the bottom? If they weren't squared, there would be a line. But squaring bends it. When the x and y are both squared and added together, it makes a different shape. If one of them were squared, yes. What if both of them are squared? Go. That's a circle. This is a circle. Prove it. Can somebody give this to me in standard circle form? That's the form we just wrote 10 minutes ago. X minus h, blah, blah, blah. Can somebody put it in that form for me? Go.
Like x minus 0 squared.
Good. X minus, you notice there's absolutely nothing subtracted? You are correct. There's absolutely nothing subtracted. X minus 0 squared plus what?
Y minus 0 squared.
Y minus 0 squared equals what squared?
5.
5 squared. Okay. So that proves it's a circle. Where's the center? What comma what? Well, 0 comma 0. The center's at 0 comma 0. What's the radius?
5.
Yeah. Center is 0 comma 0 and the radius is 5. So you should be able to graph that if you want to. I would suggest that graphing, I would say do that as a last resort because graphing is kind of inaccurate. If you have an absolutely wonderful ruler, sharp pencil, no cats jumping on your lap while you're doing the problem, I speak from experience, then you might be able to get graphing to work for you if the answers are round numbers. If they're not, oops, what method would work here? Could we try elimination? What do you think? Elimination is trying to get one of the variables to cancel, like getting the x's to cancel or getting the y's to cancel. What do you think? In your humble opinion, Mary Claire? No, why not? Why can't you get the y's to cancel, for example? Yeah, you're right. Okay. There's 2 different species of y. They're not like terms. You can't get them to cancel. Y squared and negative y squared would work, or y and negative y would work, but these don't match up. In other words, when you're solving elimination, doesn't work. Elimination needs something to cancel, and they can't. So what could you use? What method might work?
Substitution.
Substitution. Substitution requires what? What do you have to do first?
We can get like one of the variables by itself.
Yes, and then do what?
And then plug it in.
And then plug it in. Do any of these look like it might be easy to get by itself?
X or Y at the top.
Sure. Pick your favorite.
X equals negative Y plus 7.
Okay. So get x by itself, so substitution. Let's find out. X equals negative y plus 7, I agree. And then what are you going to do with that?
You plug it in for X.
Yeah, where?
Um,
In this equation?
in the second equation.
Yes, correct. Anybody remember the great Aunt Helga story? Don't re-gift to the person who gifted it to you. That's right. Anybody not heard the great Aunt Helga story? Oh, come now. There's a couple people with smirks on their faces. This would be a great way to get them to burn 4 minutes in class. This is not my first rodeo, my friend. So, all right, fine. Just for the people who've never heard the story before, do I really have to do the voices?
Yes.
All right. So assume for the sake of argument that you have a long-lost great Aunt Helga. Never heard of her before except today. And great Aunt Helga is coming to visit. And pretend it's close to Christmas. Just stretch your imagination. Or your birthday, or some occasion. Anyway, great Aunt Helga shows up and at the door and says, "Oh, darling, it's wonderful to see you." Oh, and then, thanks, great Aunt Helga, that's awesome. Yeah, nice to see you too. "Oh, I have this lovely gift for you, darling. Open it, open it." And it's a box that's 4 feet by 2 feet by 2 feet. Wow, this might actually be something. You open it up, and inside is the most hideous looking vase you've ever seen in your life. It's about 3.5 feet tall, made of this sort of putrid green ceramic with like dead animal head ceramic shapes draping over the top. "Great Aunt Helga, that's really something. Oh, I'm glad you like it, darling. Goodbye." And off she goes. And you're saying, "What am I going to do with this thing? It's going to scare kids if I bring over here to." Then it occurs to you, there's an old tradition called regifting. You know, you've heard of regifting. If somebody gives you a gift and you say, "I really don't have any use for this," you give it to somebody else. Now, there's one rule for regifting. Who's the one person on earth you should not regift this to? Use common sense. Great Aunt Helga. Yeah, I dare say she'll remember it. And then you'll get the, "Oh, you didn't like my face." Then it's just drama, drama, drama for the rest of the year. However, Cousin Wally would love a dead animal head vase thing. "Dear Cousin Wally, I saw this vase and I immediately thought of you. I also thought of the time that you shoved me into the swimming pool when I was 6 years old. Yours truly, your loving cousin. P.S. Ha-ha." So, you give the thing to somebody else, nobody's the wiser, ta-da. The math moral of the story is, if you get, pretend this is the vase, if you get X from the first equation, don't re-gift it back to this. There's actually a mathematical reason why. Watch what happens if you do. If you try to plug in X into the original, let me see what happens. Go ahead and simplify that for me. Yeah. Yeah, see the negative y and the y? They cancel. It's even worse than that. 7 equals 7. I was trying to get x and y both died in the middle of my problem. That's all. So you say, like, it's kind of like you go and your mom sends you to shop for ground beef, and then you come back home and you don't have the ground beef. Where's the ground beef? Oh, I got so distracted by the gum display. Sorry, I didn't get the ground beef. What? Same thing here. If you're saying, "So, oh problem of mathematics, what is x?" Well, 7 is equal to 7. I know. What's x? Did I tell you that 7 is equal to 7? I know 7 is equal to, any idiot knows that 7 is equal to 7. You don't even need to know math to know 7 equals 7. Where's x? It's gone. Oops. Now, that's the math. Oh, by the way, let's just finish the problem first, then I'll give you the other stupid part of the story. plug this in for x. Everybody write this down. It's going to be parentheses, by the way, whenever you plug in, use parentheses. Negative y plus 7, parentheses squared, plus y squared equals 25. Everybody see what I'm doing? So we're plugging it in where it's supposed to be plugged in. We're not plugging it grade into the great Aunt Helga equation because she'll get upset. We're giving it to Cousin Wally. You don't have to remember those names, by the way. This is the Cousin Wally equation. I remember that from high school. And the college. Because, and if you want to see a professor go like this, try that. So, x squared plus y squared equals 25. Cousin Wally. No. I'm just saying now. If you don't want people like committing you into a rubber room, don't do that. This, square the first, double the product, square the last. Do not just do square the first, square the last. Square the first is positive y squared. Double the product is negative 14y. Square the last is 49. Then plus another y squared equals 25. Best do with it? There's some like terms I can put in. 2y squared plus negative 14y plus 49 equals 25. Question. Oh, math people who remember last chapter and the chapter before. Can I use algebra to solve this thing? No, why not? Two species of y. So what could you use to solve this thing? What possibilities?
You do complete the square.
Complete the square. Any other possibilities? Yeah. Factoring, if you're lucky, or quadratic formula. Right. Anything that could attack a squared. In all three of those, you have to do let's try that again in English. Let's. What's the first step you have to do? Something you have to do before you even start solving. Go. Set it equal to 0. Tell me how. Right. You've got to get this equal to 0. Unless algebra solves it, and that's kind of lucky, you have to get the answer to 0 if you want to solve anything in life. There's got to be a metaphor for that. Now look. So 2y squared plus negative 14y plus, hang on a second, 24? I think. Somebody double check my math, but I think that's right. Okay, math people. Take over. Katie, take over. How do you solve this thing? What would you do?
Pull out a 2.
Yeah, there's a GCF of 2. So what's left behind?
Y squared minus 7y
Uh,
plus 12.
all right. Now what? Does it factor anymore? I'll open this up to anybody. Yeah.
X or y minus 3. Right. Oh, maybe not that way.
That's actually right.
Oh, yeah, okay, yeah.
Yeah, what
Y
method
minus
are you
3, y
using?
minus 4.
This-
Just
Unfoil. Find two numbers that add up to negative 7, multiplied by 12. Y minus 3, y minus 4. Solve for me.
so then we'll get,
This is a dud.
So then it'd be y equals 3,
Yep.
and y equals 4.
And y equals 4. You got two different solutions. Congratulations, by the way. Are we done? Nate? No. What do we still need? X. By the way, if you have two y's, how many x's are you going to expect? 2. Pretend that y is 3. Find x. How? Yeah, plug it in where? You can do the top one. Can you do this one? Theoretically, yes. I'll tell you in a minute, but which one looks easier? Yeah, and by the way, this is just another version of the top one. The exact same thing. So go ahead and crank it out. X equals what?
3 plus y equals 7.
Okay, oh, you did that one. So 3 plus y equals 7. Keep going. Okay, what do you get? Y equals 4. So if, wait a minute, we wanted to get x. That's Try that again. X plus 3 equals 7. Yes, what do you get? Go ahead. Yes, there you go. Now, if y is 3 and x is 4, give me the point they're talking about. Okay. What comma what? 4 comma 3. That's one of your solutions. You have not done this one yet. This is a separate problem. Josh, take over. Yeah, go for it. Okay, so x plus 4 equals 7. What's x? X equals 3. Give me the point that you found here. 3 comma 4. Let me show you the graph of this thing. And I'm going to have you help me. Can somebody please graph this? What shape is it, first of all? Place.
Line.
The line. What form?
Is that intercept one?
It would be x over a plus y over b is 1.
Oh.
Yeah, but I'll give you a hint. It's 1x plus 1y. There's slope intercept, standard, point slope, intercept.
Is that standard?
That's standard form, correct. How do you graph standard form?
I don't remember.
I stink at Pictionary, sorry. Go.
Chubby
Chubby hand method. Or you can turn it into slope intercept form. In other words, pretend that y is 0 and get the x intercept. Pretend that x is 0 and get the y intercept. So give me the two intercepts while you're at it.
They just both be 7.
Yeah, there's 7. Graph those, please, on your paper. Try and do these as evenly as possible. I'll give you graph paper on the test, so you don't have to stress too much about it. But try and be accurate for the sake of this. Okay? Can somebody graph the other equation? X squared plus y squared equals 25. Here's the other version of that, by the way. Direct me. Rainey, where's the center of this thing? 0, 0. Okay. What's the radius? 5. So go to the right 5, up 5, left 5. I gotta make sure I do it evenly so it doesn't look like an egg. And then down 5. Okay. Here's kinda, sorta. Whoops, darn it. Hang on. How many times did the graphs hit? Go. 2 times. Where? Now, this is actually a good, wow. This is actually a good demo here because my graphing was so awkward and so inexact that it's really hard to tell where they cross just by looking at the graph. Can somebody tell me where they cross without looking at the graph?
It'd be 4 comma 3 and 3 comma 4.
This is 3 comma 4. And this is 4 comma 3. You just solved it out. Does that make sense? All right. Now I got a bit of a surprise for you. There is a rule I have to teach you that never had to worry about it when we were doing lines. But as a rule for solving systems. Please write this down. When solving, would everybody know what I meant by back substitution? That means you get the x first, and then you back substitute it. You substitute it back in. Does that make sense? So if I use the phrase back substitution, you know what I'm talking about? In other words, you do all the work and you get x first, and then you back substitute it in order to get y. That's all I mean. It's nothing complicated. I just want to make sure you know what the phrase means. When solving, only only back substitute into the equation of lowest degree. Please write that down. That's quite important. I'll tell you why in a minute. When you're solving these things like this, always back substitute into the equation of lowest degree. What does that mean? Lowest degree. What does degree mean in algebra? Okay, what do you think? Like, what's the degree of this equation? 2. Why do you say that? Yeah, true. What's the degree of this thing? 3. Why do you say that? It's the highest exponent. Right. The highest exponent in the equation is called the degrees. So even if you have bigger numbers, the highest power is what we need. In this case, both of them are tied for first, so it's degree of 2. What's the degree of the top one? Adam? It is exactly, it's 1. Down here, it's degree of 2. Up here, degree of 1. According to this rule, if you get x or if you get y first, where should you back substitute it? Top equation or bottom? Josh? Which should I plug into for back substitution? The top equation or the bottom? Don't whisper. Not helping. The top, to explain. Right. If you have an x and you need to plug it back in to get the y, do not plug it in the high degree formula, plug it in the low degree formula. Not just because it's easier. It is. It's way easier. But you'll also get the wrong answer if you do it in the other one. Let me show you. You'll get half right answers and half wrong answers. I can squeeze it in down here. Over here, we did this big blah 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 blah. So work erased, sorry. You don't have to write that down. But that's in the previous one. I erased all the evidence of my previous work. And I got x equals, I got y is equal to 3, and y is equal to 4. And now I want to plug them back in. What happens if I plug them in the wrong equation? In other words, I want to try and plug it in the x squared plus y squared formula. It looks like this. X squared plus, x squared plus 3 squared equals 25. Somebody solve that for me? Same. X squared plus 9 equals 25. Keep going. Okay, so x squared equals what? 16. Keep going. Square root. What do you get? 4. Interesting. Try the other one. Let me see. Nick. Try y equals 4. What would it look like?
X squared plus 4 squared.
Equals 25. Keep going.
Squared 16.
16 equals
25.
Okay. Keep going.
Minus 16.
Okay. So x squared equals what? 9. So x equals what?
3 or negative 3.
Yeah. Do you notice something different than when we first did it? When we first did it, we have y equals 3 and x equals 4. This time it's y equals 3 and x equals 4 or negative 4. This came up with 2 points. It was 4 comma 3, negative 4 comma 3, according to this. You see, this would give you the one up here. This would give you the one down there. Both of them had a y equal to 3, but they had 2 different values of x. This thing, if you start with y equals 4, I have 2 different values of x. How many solutions is this claiming? Mary Claire? 4. Does this line hit the circle 4 times? No. 2 of those answers are wrong. If you back substitute into the high degree formula, you will get extra answers that are wrong. They're just wrong. They're basically predicting that it hits down here and down here, and that's just not true. Make sense? So 3 comma 4, oh, I guess it's up here, and 3 comma negative 4, or negative 3 comma 4. 3 comma 4, negative 3 comma, yeah. So I got this one, and then I also got negative 4 comma 3. This one and this one, I guess. But those are wrong. Does that make sense? So, 2 things I need you to know. When you're solving with things other than lines, usually the only method that'll work is substitution. There are some exceptions. I'm going to show you one exception today. But that's one. Usually substitution is what you need to solve these high degree things. Second, if you do, back substitute into the thing of lowest degree. Now if everything is degree 2, you can pick whichever you want. Because what's the lowest of 2 and 2? It's 2. You just pick one. But if there's a degree of 2 and a degree of 1, you must plug it into the degree of 1. You must. Otherwise you're going to get a bunch of answers that are wrong, and you'll have to weed them out from the ones that are right. And it may be a little bit of a challenge to do that. Good? Questions? Yeah.
So, let's say you had a graph of like x cubed.
Mm-hmm.
Couldn't you have a line that crossed it 3 times?
Yes. As a matter of fact, we'd expect that. I can show you. Actually, I'll show you later. We're running out of time. But yes, short answer is yes. You'd get 3 values of x. And you'd have to plug, and get the 3 values of y. But again, plug it into the lowest degree. Otherwise, you might get 6 answers that are, 4 of them are wrong.
Do you have a name for that, like the other one?
Oh, like tangent versus secant?
Yeah.
If it hits 3 times, no. They didn't find a nickname for that, unfortunately. Which is kind of a shame. I kind of like the name triple secant myself. But. Try this. Last thing for today.
3 times.
Try these. X squared plus y squared equals, hang on a second, 17. And 2x squared minus 3y squared equals, hang on a second, 29. Solve. What shape is the top? Yeah. It's a circle. How do you know that? Yeah, both variables are squared, and there's an addition sign. And it looks like, now the radius on this top one is going to be not very nice. Can you tell me what the radius is? What is it? It's radical 17. This thing has a center at 0, 0, which is nice, and a radius of radical 17, which is not very nice. It's a little bigger than 4. In other words, I would not want to graph this thing unless I absolutely had to. What is this bottom shape? We don't know. But question, is it a circle? Why not?
Because the height multipliers, or other height multipliers.
Ah, there's 2 reasons why not. We've got height multipliers, which might goof it up. Actually, this is a height multiplier. This is actually called a width multiplier. But they're different, so it's going to be weird. And there's one other thing that's goofing it up. Subtraction. What is the shape? We do not know yet. By the end of next week, you will know. It's one of the 4 shapes. But for now, solve. All you need is algebra. Don't graph this thing. It's a nightmare. For now. What do you think? What method might you use? Go.
I do, what's it called, canceling?
Yeah, what's that called? Starts on E. Was it? It's elimination, right. How would you do elimination? Who wants to take this? Who's feeling brave? Okay. Go.
You need to multiply the top by 3.
Multiply the top by 3. If you want to get the y's to cancel, do that for me.
It'd be 3x squared plus 3y plus.
Squares equals.
Uh,
I would do 10 times 3 and 7 times 3 and put them
so
together.
it'd be like 41,
One more.
50.
Good. 51. And then the bottom keep the same. Nate, take over.
Threes cancel.
The 3 y's squared, you mean? What do you have left?
5x squared
Okay.
equals 7.
80. Now what? Josh, take over. Divide by 5, what do you get? X squared equals. How many times is 5 going to 8? There you go, 16. Good. What's X? Ah. I got 2 different solutions. I got 2 X's. How many Y's should I expect? 2. Maybe. Mary, take over. Try the X equals 4. I want to find Y. Where would you plug it in? Maybe. Could I plug it in the bottom?
Yeah,
Yes. Why would I? Why?
because it does the same power.
Right. What's the word? Starts with D.
Degree.
Same degree. They're both degree 2. Correct. So, and I know it's kind of warm in here. Plug it in the top because it's easier. We're trying X equals 4.
So it'd be 4 squared,
Mhm.
which is 16, plus y squared equals 17.
Okay.
And then subtract 16.
16 plus Y squared equals 17. Okay. So what do you? Y equals what? Y squared. Wow.
Y
Can't talk.
squared equals 1.
Good. So what's Y?
Y equals 1 negative.
Ah, stop. Everybody look up here. I know it's near the end of the hour. I know everybody's kind of tired. I know it's kind of warm in here. It's making everybody sleepy. But wakey, wakey, and watch. This is key. You got X equals 4. We have not even touched X equals negative 4 yet. How many Y's did I get for this single X?
You have 2.
2. Tell me where these points are. What comma what and what comma what? Nate. Say again? You want the question repeated?
No, I'm just not sure.
Okay. What did I ask?
No, I'm just not sure
Okay.
what it is.
What did I ask?
What comma what?
Yes. So what is it?
I don't know.
Now, what letters do you use?
X comma
Yeah, what's X?
4.
4.
1.
That's the first one.
Negative 4.
I haven't used that one yet. With this single 4, I got 2 different Y's. Use this single 4 both times. Go for it. Do you see what I just did, everybody? Don't just nod your head and say, I'll get Mr. Cochran off my case. I have not touched negative 4. It never even came into the problem yet. When I plugged a positive 4 for X, I got 2 different Y's. So it's positive 4 comma 1, positive 4 comma negative 1. I got 2 different points for one input. Now, try the other one. Josh. Plug it in. I'm plugging it in the top. It's easier. Negative 4, missing something. Squared plus y squared equals what? Keep going. 16. Please don't put negative 16. Plus y squared equals 17. This should look familiar. What's y squared equal to? 1. Keep going. Y equals 1 or y equals negative 1. What does that mean? What 2 points did you just come up with? Go. Negative 4 was the x we're using. Negative 4 comma 1, negative 4, negative 1. We have 4 solutions. And by the way, I'll show you why. X squared plus y squared equals 17 is roughly like this. You don't have to draw this until next week. This other one looks like this. Yes, basketball. But, did anybody recognize this shape just from yesterday? Yeah,
And a hyperbola.
it's a hyperbola. How many intersections are there between the hyperbola and the circle? Go ahead.
4.
4. 1, 2, 3, 4. 4 comma 1, 4 comma negative 1. Negative 4 comma negative 1, negative 4 comma 1. See? How did I graph this one? Because I cheated and I knew the lesson from next week. How did I graph this one? By knowing what we know. I went up radical 17, like 4 point something. Down radical 17, left radical 17, right radical 17. And then the only reason I knew there were 4 intersections is because of this stuff. I had absolutely no clue. Because sometimes they say, hey, wait a minute, doesn't a hyperbola always hit a circle 4 times? Nope. Sometimes it hits 0 times. Do you think it could ever hit once? A hyperbola in a circle? Yep. Could it hit twice? Yeah, there are actually 2 different ways it could hit twice. Like this, or if you're really, really, really careful, like that. Could it hit 3 times? Yes. If you're perfect on this side and overlap on the other. So it can hit 0, 1, 2, 3, or 4 times. How am I supposed to know which one is which? I don't, until the algebra tells me. If the algebra comes up with 3 solutions, I know it's like this. If the algebra comes up with a bunch of imaginary solutions, I know it's like this, where it doesn't hit at all. Does that make sense? All right, this, God willing, is the last day where I'm going to stall the test. I am working hard on those. I'm trying my best to give everybody partial credit on these things. So tomorrow, please pray for me. I'll get those things to you. Pray for my Wi-Fi too. It's dead. But here, not at home. At home it's nice, but here. Any last questions? Don't do a brain dump of this stuff. This is going to be this chapter coming up. Please stand. Let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Somebody hit record. Bye.